Alright, so we're being asked here for question 1 to find the line that is parallel to the line y equals 2x plus 2 and passes through the coordinate 1, negative 1. Every line in the history of lines can be represented by what equation? Y equals mx plus c. So we want some y equals mx plus c to be our final answer. What values there should be represented with numbers instead of letters? So we need the m. No, with this pen we don't. We need the m and the c, correct? Immediately when I look at this problem, what are some key words? Harry? Parallel. So what does that tell me before I go any further about this line map? What do you know about the line when it says parallel?
2 lines.
Yeah, we're going to have 2 lines, and what's the gradient for both lines going to be? Yeah, so not x is not part of the gradient, but the 2 is. So very good. So we know m equals 2. Happy with that? What don't we know? The c, the x, or the y. Now x and y can be anything, correct? But we know it needs to be something at some point. So let that sink in for a second. X and y can be anything. However, at some point we know those values, but we don't know our c at all, correct? How many unknowns can we deal with? 1. We can deal with 1 unknown in an equation by itself. So I know right now y equals 2x plus c. That's what I know. Or do I know something more? Liam, what else do I know?
In the equation it's 2, it's plus 2.
Oh, so in this equation there's a plus 2. Okay, very good. But I want a line that's parallel to that line. So is there something that can help me out with that? Isabel?
The negative 1 and the y-intercept.
Is it the y-intercept? I think we know something about negative 1 and y. I'm just not sure it's the y-intercept. Pat, what do you reckon we know?
We know that it passes through 1, negative 1.
It has to pass through the point 1, negative 1, correct? So we know with this line here that when y equals negative 1, x equals 1. Do we know that? Is that a definitive fact? If it passes through that coordinate, 1, negative 1, when x equals 1, y must equal negative 1. So now how many things, if I rewrite my equation, will I not know? What's that one thing? C. So negative 1 equals 2. What's my x? Times? Plus c. What should I do now? Well, simplify, then I'll rearrange. So negative 1 equals 2 plus c. Now I need to do my rearranging. How should I do that? Thanks, Braden. What do I want by itself? I want to find out what c is, so I need to get that by itself, don't I? What's stopping it? The 2 plus, so how do I get rid of a 2 plus?
You gotta go to 2 minus and 2
Minus 2 from both sides, very good. The 2's cancel. I'm left with c equals. Now I rewrite my equation. Tell me what I should write, Cameron, when I rewrite my final equation. What form do I want it in? What do all lines come in the form of? Yeah, oh, we could draw it. We're going to draw it in a sec to check it on Desmos, but
a linear equation.
I need a linear equation which is in the form y equals 2x minus 3. How would I check that on Desmos?
that
I'd put this function in,
to the thing
and then what would I be looking for?
put the other function as well.
Well, that'll prove that it's parallel, so yes, I should do that. I should put both my functions in. But what do I want to know?
Make sure that it goes through 1, -1.
I want to make sure this function runs through 1, -1. Is there a way I could check without Desmos? Without sketching it? Harry?
Make one of those orders while x still.
Yep, so I could let x equal 1. What's 2 minus 3? -1. Have I proved that it goes through that point? Very, very good. I'm going to give you a chance to mull on that, write that down. You're going to have a go at question 2 on your own, and then I'll show you how to do that. Just going to revise the summarise what we've done very quickly. We know all our functions come in the form y equals mx plus c. Using our knowledge of parallel and perpendicular equations, what can we do? What do we find out immediately? My gradient of my line. And then what do I use to find my unknown c value? I know the coordinates, so I let y and x equal whatever my coordinates are, leaving me with one variable. And then I shove that back in my general form. Sweet. Same process, parallel or perpendicular, just different gradients. Off you go.